Collision. There are two main types of collision: elastic collision and inelastic collision. During any collision, the total energy of the system is conserved according to the law of conservation of energy. Elastic collision. A collision in which both momentum and kinetic energy are conserved is referred to as a completely or perfectly elastic collision. In this system, no kinetic energy is lost to heat, sound, friction, or deformation of the object. In this case, after the collision, the object moves apart, usually in different directions. Let's say we have two objects with masses ma and mb, moving with initial velocities ua and ub, and final velocities of va and vb after collision. From the conservation of linear momentum, maua plus mbub is equal to mava plus mbvb. The kinetic energy of the system is given by half maua square plus half mbub square is equal to half mava square plus half mbvb square. This is the kinetic energy before collision, and this is the kinetic energy after collision. Examples of elastic collisions are ideal gas molecules or a spacecraft gravitational axis near a planet. Collision between very hard spheres like billiard balls are close approximation. Inelastic collision. In contrast, an inelastic collision is a collision where momentum is conserved but kinetic energy is not conserved. Some of the kinetic energy is transformed into other forms such as heat, sound, friction, or deformation of the object. That means kinetic energy decreases after collision. This is a special case where the two bodies stick together after impact and move with a common velocity v. That means Va is equal to Vb, which is equal to V. Conservation of linear momentum equation becomes maua plus mbub is equal to ma plus mb in bracket V. The energy of the system is given by half maua square plus half mbub square is equal to half ma plus mb in bracket v square. Examples of inelastic collisions are a car crash, a baseball hitting a bat, or a ball of clay hitting a wall. Perfectly elastic collisions are rare in the real world. They are a useful model for certain scenarios like interaction between billiard balls or ideal gas particles, while inelastic collisions, which are common in everyday life, result in damage or deformation such as a car crash. Example: a tractor of mass 5.0 times 10 raised to power 3 kg is used to tow a car of mass 2.5 times 10 raised to power 3 kg. The tractor moved with a speed of 3.0 meter per second. Just before the towing rope becomes taut, calculate the speed of the tractor. 2. Loss in kinetic energy of the system just after the car has started moving. Given mass of tractor mt is equal to 5.0 times 10 raised to power 3 kg. Mass of car mc is equal to 2.5 times 10 raised to power 3 kg. Initial tractor speed ut is equal to 3.0 meter per second. Car is initially at rest. uc is equal to 0. Assume the tractor and car move together immediately after the rope becomes taut. Perfectly inelastic coupling. Using the formula mt ut plus mc uc is equal to mt plus mc, all bracket close v. Substituting 5.0 times 10 raised to power 3 times 3 plus 2.5 times 10 raised to power 3 times 0 is equal to 5.0 times 10 raised to power 3 plus 2.5 times 10 raised to power 3, all bracket close v. 15 times 10 raised to power 3 plus 0 is equal to 7.5 times 10 raised to power 3 v. V is equal to 15 times 10 raised to power 3 divided by 7.5 times 10 raised to power 3. V is equal to 2 meters per second. Loss in kinetic energy of the system. Initial kinetic energy, only tractor moving. So kinetic energy initially half mt ut square plus half mc uc square. Substituting half times 5,000 times 3.0 square plus 0, since initial velocity uc of the car is 0. Car is at rest. Initial kinetic energy is equal to 2,500 times 9. Initial kinetic energy 22,500 joules. Final kinetic energy, both the tractor and car moving. Final kinetic energy is equal to half mt plus mc in bracket v square. Substituting, final kinetic energy is equal to half 5,000 plus 2,500 in bracket multiplied by 2.0 square. Final kinetic energy is equal to 3,750 times 4. Final kinetic energy is equal to 15,000. Loss in kinetic energy is change in kinetic energy, which is equal to initial kinetic energy minus final kinetic energy. Substituting 22,500 minus 15,000. Change in kinetic energy is 7,500. That means loss in kinetic kinetic energy is 7,500 joules. Hope you enjoyed the lesson. If you have any question, you can drop them at the comment section below and I'll respond to them as soon as possible. See you in the next class.